Okay, here we go. The start of trig. The next 6 months of your life will be devoted to trig. Well, 6 weeks anyway. We'll get you a timeline. So don't worry about any of this, the homework for tonight, right? Because you're worried about the quiz tomorrow. Okay, so tonight is for studying for the quiz tomorrow. Tomorrow night is for worrying about any homework that goes along with it. But I'll give you a reference for it. Okay, angles and angle measure. So some of this is reviewed 20-1 stuff. Recall from 20-1 that an angle is in standard position on a Cartesian coordinate plane if its vertex is at 0, 0, or the origin. So we'll say 0, 0. And its blank is on the positive x-axis. What's on the positive x-axis? Its initial arm. Rotating the terminal arm in a counterclockwise direction results in a positive angle. And rotating the arm in a clockwise direction results in a negative angle. Right? So all you got to do is look at that clock and say, I don't know what's clockwise, it's digital. So then you have to switch your clock to one that has hands, then you say, all right, clockwise. So clockwise is climbing around the clock, right? 1, 2, 3, 4, 5, 6, 7, 8, etc. Counterclockwise is going backwards, right? So clockwise is a rotation, this is a clockwise rotation, and counterclockwise would be the other way. Since a standard position angle is a result of rotating the terminal arm, and a rotation can be more than 360 degrees, angles in standard position have unlimited size. So I can have an angle of 720 or 1080 or 1,672,416.3 degrees. Right? So unlimited size. The reference angles, in other words, so we can all talk about the same thing. We have this thing called the reference angle. Is the acute angle formed by the terminal arm of the angle and the x-axis. Reference angle is always positive. Okay, so no matter which way, when you draw near a reference angle, you're not worried about, is this a clockwise rotation or counterclockwise rotation? We're just saying the reference angle is a positive angle. Okay, what's next? By convention, angles are usually labeled with letters from the Greek alphabet. Some of the more common ones are listed below. What's the name of this one? Beta. Although if you're Greek, you would say theta. What's the name of this one? Beta. Although if you were Greek, you would say beta. And this one is? And if you were Greek, you would say alpha. You put together alpha, beta, and you get the alphabet. Where the word alphabet comes. Those are, no, seriously, it's done. Where did that come from? The first 2 letters of the Greek alphabet are alpha, beta. You've probably heard of from alpha to omega. What's omega? It's the last letter in the Greek alphabet. So when we say, if the statement is from alpha, it's like saying from A to Z. Right? Like everything. So from the alpha to the omega covers up. View demo regarding angles of rotation. Demo for angles of rotation. So initial arm runs along the positive x-axis. The terminal arm does not. The terminal arm is where you've rotated to. Here's in degrees. So 0 degrees. Now this is of course different from a navigational protractor, which would be turned this way and the degrees go the other way anyways. Right? So it's kind of a confusing thing, right? I mean, if you're doing your pilot's license or something like that, navigation, 0 degrees at the top, and then we rotate, positively rotate in a, goes this way, it goes counterclockwise is positive. No, sorry, clockwise is positive. Okay, we don't have to worry about that, right? We're doing math degrees. Well, nobody's post-secondary, you can do a math degree. So 0 degrees, 10, 20, 30, 40, and so on. This is just counting the other way, and it counts up to, outside, up to 360 degrees. Okay? But 0 degrees lies along the positive x-axis. Unit circle. Supposed to do unit circle yet? Probably not. Whoops. Draw each rotation angle for theta or beta, in standard position and state its reference angle. So we're going to say theta sub r. So if I'm referring to a reference angle, it's going to be theta r, beta r, alpha r, gamma r, etc. So theta is 162 degrees. Where do I draw theta? In quadrant 2, right? So we know this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and back around would be 360. So 162 lies somewhere in here. We indicate it by drawing a rotation in a counterclockwise or positive direction, right? It's positive 162 degrees. I indicate that with a positive rotation. And I say, here's theta. And here's theta sub r. And what's theta sub r equal to? Or just going to say, what's the reference angle? 18 degrees, right? How do you figure that out? Yeah, 180 minus 1. So I just say I'm at 162. How much further do I have to go to get to 180? The actual calculation will be 180 minus 162, right? Or you won't even think of the calculation. You'll just figure it out and say 18 degrees. That's what you want to get to, just where you look at it and you say it's 18 degrees, right? Without going through the, oh, it's 180, you know. 420 degrees, how do I indicate that? So we start at 0, we go 90, 180, 270, 360, and then we're going to stop there. I'm putting an arrow on to indicate the direction of rotation, which is positive. I draw in my terminal arm, and I say that this is the angle theta. So there's theta, right, which is the reference. And what is the reference angle? So this is theta r, which is always positive, right? In this case, it's positive. Oh, we have outlines. 60 degrees. Look, the timeline was just updated. Oh, okay. We'll have a timeline. We can't get through it, so we're okay. Boom. Beta, or beta, is negative 95 degrees. Which way do we rotate? We rotate in a clockwise direction. This will be negative 90. So again, this is 0. If I'm going negative, that's negative 90, negative 180, negative 270, and negative 360. Okay, so that's negative 90. I want to go a little past that. So this is theta. This is my reference angle, theta r. So I just say, how much further do I have to go to get to 180 or negative 180? So how big is this? That's 5 degrees, right? So 95 is 90, 95. There's 90 degrees in a quadrant, so you got to go 85 more degrees, right?
It's beta, not beta.
Right. Beta. Apparently, beta's saved for the negative angles here. Negative 400, what do? Well, I go negative 90. So negative 360 is once around, and then I want to go 40 more degrees. I'm indicating my rotation, right? That I'm going around in a clockwise direction, so it is a negative angle. This angle is beta. This angle in here is beta r, the reference angle, which is 40 degrees, right? So I just think I went 360, and then I went another 40. So, okay, it's just 40 degrees, right? My reference angle. Reference angles are always positive. Right? So far, so good. Different standard position angles with terminal arms in different quadrants can have the same reference angle. Complete the following table by stating the standard position angle between 0 and 360 with a terminal arm in the indicated quadrant. Okay. All right, so the reference angle is 30 degrees. What's the quadrant 1 angle? So we draw a little cross there, we indicate a quadrant 1 angle with a reference angle of 30 degrees. That's here. So I say that's 30 degrees. So what's the rotation angle? 30. Okay, so we would say 30 degrees is the angle. If the reference angle is a 30-degree angle in quadrant 2, then what's the angle? 150. Why 150? Yeah, so it's 180 degrees. Basically, say here's 180, but I need to back up 30 degrees, so it's 180 minus 30 degrees, okay, which will give you 150. If I have a quadrant 3 angle, reference angle of 30 degrees, what's my rotation angle? 210 degrees. How do I get that? Well, you go to the x-axis, right? The x-axis is either 0 or 360. So 0 if I'm counting up this way, 360 if I'm trying to get back to it. This is 180, 180 and 30, so it's 180 degrees plus 30 degrees. And if I have a quadrant 4 reference angle of 30 degrees, and remember, it's always positive reference angle, then what's my rotation angle? 330 degrees. And how do I get that? Now, usually, if I'm doing it, I just say, what angle do I have to go 30 more degrees to get to 360, right? Like, and this is the math that you're doing in your head, or where you're going 360 minus 30. Okay, you do the same thing for 72 degrees. So you're going to put a reference angle of 72 degrees into each quadrant and come up with the actual angles. Okay, so here's for 70, is that right? Yeah, good. Okay, so there's for 72 degrees, right? You're putting a 72 degree reference angle, which means the angle between the positive x-axis and the terminal arm will be 72 degrees. You should make it reasonably accurate. Don't draw this and say, here, this is 72 degrees. That's more like 27 degrees. You know, making it reasonably accurate is going to help you when you go look at the angle. You're not going to get the wrong angle. You say, wait, that doesn't seem right because my diagram is off. Okay, now we do this in general. So I have an angle of theta r in quadrant 1. What's the angle? So the angle is just theta r, right? So in quadrant 1, the reference angle is the angle. If I have a reference angle of theta r in quadrant 2, what's the angle? So 180 minus theta r. If I have a reference angle of theta r in quadrant 3, what's the angle? So 180 degrees plus theta r. And in quadrant 4, I have a reference angle of theta r. What's the rotation angle? So 360 minus theta r. Okay, so that's how we get our angles. It should become second nature to you pretty soon, right? Like, I don't really think about this a whole lot when I do them. You just should kind of know how to do it. Reference angles in which the terminal arm lies on the x or the y-axis give all the angles between negative 360 degrees and 360 degrees inclusive, right? So we're including both ends, that have a reference angle of 0 degrees. So if the reference angle is 0 degrees, then we are looking along here. So this is the only one that has 0 degrees. Well, sorry, it's not the only one, but 0 degrees is one of the angles that has. Now, there's another angle. Where else could we be? We could be along this axis. Reference angle 0 degrees, but what's the rotation angle? Okay, because we're looking for angles between 0 and 360, so this angle is plus or minus 180 degrees. Okay, and then a third one is just lying along here again. So what's the angle now, or now? So what's this angle? 360 degrees, and what's this angle? Negative, so plus or minus 360, right? So 0 degrees, now note I'm showing the rotation. There isn't a rotation, right? It's just on 0 degrees. 180, okay, the rotation is 180 or negative 180, and if I go 360, that's why these two guys are separate, right? So they're the same angle. Okay, 90 degrees, so where's 90 going to lie? So it could be straight up. And my reference angle is, or sorry, my rotation angle is what? This one, 90 degrees, this guy, negative 270 degrees. Remember, we're looking for the angles between negative 360 and 360. So either a full rotation clockwise, or a full rotation counterclockwise. Okay, where else could we get 90 degrees? Could be going down here. And my, excuse me, my angles are, so 270 degrees or negative 90 degrees. Okay? So those are reference angles which lie along the axis. They're also called quadrantal angles, okay? Because they're really splitting the quadrant. So those angles are 0, 90, 180, 270, 360, or negative 90, negative 180, negative 270, negative 360. Draw the standard position angles, 100, 460, negative 260, and 820. Okay, go ahead, draw those angles. How will you indicate the angle? With the rotation arrow, right? So for 100 degrees, you're going to say, well, it's like up here. And you're going to say, all right, that's 100 degrees. And then you want to draw 460. You want to draw a negative 260. And you want to draw 820. So 360, no, going the wrong way. 360, 720. So there's 800 degrees. All the above angles are coterminal, meaning their terminal arms are in the blank position, same position on the coordinate plane, but the amount of rotation is, yeah, not the same or different. Oh, 820, yeah, sorry. The amount of rotation is different, right? And is indicated by your little rotator thing, right? Which tells me, hey look, this is positive 100. Hey, this is positive 460, right? I've gone around once and then I've gone 100 degrees. The blank angles of coterminal angles are so the reference angles are so what's the reference angle for each of these guys? What's theta r? 80. What's theta r? 80. What's theta r? And what's theta r? Okay. So the reference angle is a positive acute angle, right? It's positive, it's less than 90 degrees. So the reference angles are the same. When an angle's in degrees, to find a coterminal, what do you add or subtract? 360 degrees, right? So 460 is 100 plus 360. 100 minus 360 gives you negative 260, and so on. So subtract increments of 360 degrees. And what's 360? Just once around the circle, right? So if I'm here, and then I just go around 360 degrees, I'm back here again. If all we're looking at is a reference angle, if you just drawn that angle, right, and if I label this even as theta r is equal to 80 degrees and say, what's this angle? And you say, well, nobody indicated anything. So it's 100, or it's negative 260, or it's 460, or it's 820. Okay, so without an indicator, it could be anything, like 100 plus or minus. So write two positive coterminal angles and two negative. So we're going to do what? 123 degrees plus? Plus how much? Plus 360 degrees. What's that going to give us? 483 degrees. And we're going to do what next? We're going to do 123 degrees plus 2 times 360 degrees, which is 3, 4, like 843. It is like 843. What if I want negative coterminal angles? Then I start with 123 degrees and I subtract 360, which gives me, what, 37? It's like negative 237 or something. And I start with 123 degrees and I subtract 2 360s, which is, how much? Negative 597 degrees. We always need the degree symbol, right, to indicate it's in degrees. Okay, if I have negative 400 degrees, I want a positive coterminal angle. Will adding 360 do anything here? Well, it'll do something, but it won't give me a positive angle, will it? So let's go over here to the negative coterminal angles, and I can say negative 400 degrees plus 360 degrees is how much? Negative 40 degrees. So how many 360s am I going to have to add? So at least 2. Okay, and this will be what? 320? And if I add 2, then what am I going to add for the next one? I'm going to add 3 of them. Okay, you don't have to. You could add 4 of them or 10 of them or whatever, but you know, if we just stick with working out sort of the next one. And what's that going to work out to? 680? And then what am I going to do here? I'm going to subtract 360, and that's going to give me negative 760 degrees. Right, so you add or subtract multiples of 360 degrees. And all it means is from your terminal arm, from where you're at, you're just going around once, counterclockwise or counterclockwise, right? And you get back to that same arm, right? Coterminal, same terminal arm. State all angles coterminal with 200 degrees, where beta is between negative 720 and 720. Okay, so what do? We start with 200, so let's go down first. So 200 degrees minus 360 degrees will be how much? Negative 160. Couldn't get those calculators out fast enough. Oh, look at this.
Still warm.
Still warm. Not whole time. The copier doesn't do. So you do whatever's next. Get the rest. You've got negative 160. Do you have to go down further? Yes or no? Should we go further down? Okay, so go further down. So then what? 200 degrees minus 2 360s is negative 520. Should I go down some more? No, if we do, we're going to go below negative 720, right? We don't do that. So let's go the other way. 200 degrees plus 360 is how much? 560. Should I go up another 360? And the answer is no. Take one, pass it around. Okay, so these are all the angles between negative 720 and 720, right? Any other, if we go below, we'll be below negative 720. If we go above, we'll be above.
We have to like state them ultimately in 200 degrees.
Ah, this is the question then. So do we include the 200 degrees? Yes or no? Is 200 coterminal with 200? And we say no, just by definition. Okay, so the coterminal angles are negative 520 degrees, negative 160 degrees, positive 560 degrees, not 200, okay, so not 200 degrees, right? Awesome. So 200 is not coterminal with itself, it just is itself. Write an expression for all angles coterminal with beta. Okay, all angles, so what are we doing here? We're going to have 200 degrees, and then what do we add or subtract? So we subtracted 360, we subtracted 2 times 360, we added 360. What do we add or subtract? A multiple of 360, right? So we're going to go plus 360 degrees times n, where n is an integer. And n is not equal to 0. Okay, because 200 is not coterminal with itself. Okay, so we take 200 degrees plus 360n. You might say, what happened to the negative? Well, n is an integer, right? It's 1. 200 plus 360 is 560. It's negative 1. 200 plus negative 1 times 360 is 200 minus 360, and so on. So this is what we're going to look for when we look for a general solution to something. Okay, since all those angles will have the same properties, right? They all have a terminal arm. Sorry, they're all 200 degrees, coterminal with 200. Then each of those angles will work. Radians. Question came up earlier today. Radian measure. Why are there 360 degrees in a circle? So why 360? Why not 400? Yeah. Yeah, but it's got nothing to do with it. Why 360 degrees? Why not 400 degrees? Why not 1,000 degrees, right? Then each quadrant is 250 degrees. Or 400 degrees, so right angle's 100. Wouldn't that make more sense? Okay. That's actually called grads. You ever have a DRG key on your old calculator in junior high? The G is for another measurement, which is called gradients, I think, or grads. That's a 100-degree quarter circle. Grads is a 400-degree circle, right? So somebody came up with that. But why do we use 360? I blame the Babylonians. Who else, right? I mean, there's almost 360 days in a year. Not quite. 360 is divisible by a whole pile of numbers, right? 2 goes into it, 3 goes into it, 4 goes into it, 5 goes into it, 6 goes into it, 7 not so much, nor 8, but 9 goes into it, 10 goes into it, right? There's a lot of numbers that go into 360, so it has a lot of factors, okay? So that's kind of handy there. But let's say some aliens landed on Earth. We're talking about circles for some reason, because in order to communicate, we're going to need some basic thing that we all understand, right? And we all understand a circle, right? That should be universal. There are circles, they exist, quadrants, etc., right? And we're going to go to them and say, there's 360 degrees in there. And they're going to look at us and go, what? Like, why 360? What's that got to do with anything? Well, it's a nice number, we say. Surely you have 360 degrees. And no. Why would we have 300? We have, 6,400 degrees. 6,400 is actually another measurement they use. I know the armed forces used it, like for artillery to call in, because 1 degree, when you go out a few miles and you're firing a shell or something, that's a fair distance apart, right? If you get out 10 miles, 1 degree, we're talking about a pretty good, pretty big, it's a small angle, but it's a pretty big spread. If you've got 6,400 of these things, then we're talking a pretty small spread between each of them, right? If we aim on that. All right, anyways, the unit most familiar up to this point is degrees. And now we're going to do radians. And you got to memorize your unit circle. Not yet. We'll get introduced to it today, then I'll show you different ways to remember it. You know what the measure of 1 degree looks like, right? Pretty small. But what does the measure of 1 radian look like? All right, so here we go. And this is why we could talk with the aliens about these circles. Watch and see, how is this defined? First off, definition. Arc length is the distance between 2 points measured along the circumference of a circle. So here's a circle. If I have these 2 points, this is the arc length. Okay, arc length. A minor arc length, so if it's a minor arc, it's less than half the circumference. Less than half, it's a minor arc. If it's a major arc, then it'll be blank, then blank. So if this is less than half, then it's got to be more than half. A central angle has its vertex at the, take a wild stab, center of the circle. And arms intersecting the circle. Okay, all which I'm pretty sure is on this thing here. Okay, here we go. 1 radian. And this is why a radian will make sense to anybody in this universe. 1 radian is the measure of the central angle, so an angle measured from the center of the circle, by an arc equal in length to the radius. Okay, so here's the radius, right? Take a piece of string and then lay that string here and lay that angle off. So you want this length measured along here, which I'm going to guess goes to about here. So I'm going to call this arc length is also R, and this is R, the radius, right? It's just a radius. And then this is the central angle, which we'll call theta, or theta. It's not actually pi, it's P. If you're Greek, I mean, it's, I don't think we should be telling them, here's how you pronounce your alphabet. So here's the deal. This angle here is 1 radian. Now, do you know why that's universal? Because all it uses is the radius of the circle. And the radius of a circle is constant. So if we say, you take this, mark it off along here, you got to draw that diagram for them, and we say, this is 1 radian. And they'll say, well, we call it this, but we have a name for it, right? Because it's not some arbitrary, hey, let's split the circle up into a degree. What's a degree? It's 1/360th of the way around the circle, right? Speaking of degrees, using the diagram, straight approximately how many radians it would take to complete a full rotation, 360 degrees. So basically what we're going to do is kind of use this diagram, and ideally we should have a piece of string and lay that off along here and say, okay, so here's R here, right? That's 1, and then do it again, and then do it again. Yeah, so, right, that's obviously too small, and that one I think is obviously too small. Okay, so, and then do it again. Hang on. I don't need a piece of string. That's too big. That's too small. Anyways, it works out to be 6 and a bit. It's about 6 radians will get you around. Okay. Again, this would work very nicely if you did it with a piece of string and actually laid the angle off, right? And you need a piece of string because this is not a straight line.
Yeah.
This, right? It's not a straight line, so we really would have to, or should have to lay it off. Now, we want to do exactly how many radians. So we know there are 360 degrees in a full rotation, right? Now we want to figure out how many radians are in a full rotation. Well, to do that, we need the full length of the circle, right? The arc length. Another name for the distance around the circle, the perimeter of a circle, is the circumference. What's the formula for the circumference of a circle? C is equal to 2 pi r. Wait, 2 pi r. And what's that r we were laying off, right? So it says there must be 2 pi of these r's. Okay, use information to determine how many radians. Well, it's 2 pi radiuses, which means there are 2 pi radians. Okay, so there are 2 pi. So what we'll use is this formula. if we take circumference divided by r, because we want to know how many r's there are. Well, there are 2 pi r's in the circumference, and we divide that by r, which gives us 2 pi radians. Okay, so this angle here is 2 pi radian, right? So if this is 10, right, well then, it's 2 pi r, so the circumference is 20 pi. But we say, but then how big is the circle? It's 20 pi divided by 10 is back to 2 pi, right? So it'll always be 2 pi. And it doesn't matter how big the circle is, right? If I do a little small circle like this, right, then this is the radius here and here. Big circle, this is the radius here and here. Bigger circle. So that angle doesn't change, right? As long as this is equal to r, then this will be the same r. Well, this will be r1 and this will be r2. Right, so that's R1 and R2. Wrong way. Therefore, 360 degrees is equal to how many radians?
2 pi.
2 pi radians. Let's look at more angles in radian measure by breaking the circle into smaller sections. Now, I think I have this here. Unit circle cut into, but we want 2 pieces, right? 8, 6, 4, 2 equal pieces. Okay, so if we start at 0, right? So it's still 0, right? I mean, this is 0. If I do not put a degree symbol, then the angle is measured in radians. So very important from this point forward, if you forget the degree circle and you make 90 degrees and you write 90, I will read that as 90 radians, which is like 15 times around the circle or something, right? Remember, there are 6.28-ish radians in a circle, right? 2 pi. So how far is it halfway around? How many radians from here to here? Well, we know this is 2 pi, so this must be pi. Come on, there's pi. And this must be, then if we go all the way around, what do we get? 2 pi. Okay, so you should now be able to fill in, right? Somewhere on here we can fill stuff in. So 2. So theta in degrees. Oh, what's that in degrees? Halfway around a circle. 180 degrees. The exact value, so in radians, what will this be? Exact value, rounding. 2 pi divided by 2 is pi. Oh, sorry, you were giving me the 2 decimal place answer, which is 3.14. Radians, so as long as, if you go and do this, you've now made it 3.14 degrees. This is actually pretty easy to figure out if you've got the right or wrong unit. Because if you're saying, oh, and then this angle, which you can sort of see and you calculate and say, it's 3.14 degrees. Which would mean if you were looking at it on a piece of paper, they're very close, right? It'd be very hard to tell apart the initial and terminal arms, right? And then you'll be looking at an angle. So you're looking at this angle, and you're saying 3.14 degrees, which would be like this angle, so you say, oops, wrong units. Okay, so then, what if we split into 4 equal sections? So we'll go here, and we'll back up. If I cut it into 4 pieces, so the pieces will each be pi by 2, right? Like how big is each piece? 2 pi over 4 is pi over 2. So what's up here? This is 0. What's this? It's pi over 2. Right? 1/4 of the circle. There's a movement, it's called the tau. So tau is equal to 2 pi. Tau is just another Greek letter, which I think is actually pronounced tough, but we would say tau, T-A-U. Looks like a T, tau. And tau is equal to 2 pi, right? Which means that once around the circle is tau, right? A quarter of the way around the circle is a quarter tau. It makes perfect sense, which is why we don't actually teach it. Okay. I've debated and said, well, we could teach this, but then when you get on to the exam, it's like, yeah, there aren't going to be any taus on there. It's going to be pi's. you would have to convert it. Okay, so that's 1 pi over 2. How many pi over 2's is this? 1 pi over 2. 2 pi over 2, which we would normally just say. Well, 2 pi over 2, which is, yeah, also pi. Okay, now the deal is you actually do want to count by halves, right? You want to go 1 pi over 2, 2 pi over 2, which you can then say that's pi. So how many pi over 2's to get here? 1 pi over 2, 2 pi over 2, let's keep life easy. How is 2 pi over 3 easy? If you've got 1 pi over 2, 2 pi over 2, then the next one is 3 pi over 2. Let's go back to counting. Yeah. 3 pi over 2, which does not reduce. Then how many pi over 2's are here? 1 pi, last chance. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is equal to 2 pi. So this is 0. There is a reason to count this way. And not to do, so to just go 1 pi over 2, 2 pi over 2, count it and then reduce it as is applicable, right? Because otherwise, how do you get to 3? It's like, so if you go 1 pi over 2 pi, then you have to now say like 1.5 pi, right? So if I say 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, why would I do that? Well, okay, first let's go fill in the table. All right, so 4 equal sections in degrees, what is this? 90. In radians, what is this? Pi over 2. In decimal places to 1, it is, or sorry, 2, that's 1.57. Okay, so you may see magical numbers like 3.14, 1.57, and you'll recognize those as the rounded value for 180 degrees or 90 degrees, right? In radians, though, right? Rounded in radians. Okay, what if we do 6 of these? Do we fill this? Let's do this first. So theta in degrees. So what's it in degrees? How many degrees? Okay, so it's 1, 2, 3. It's a third of 180, 60 degrees, right? Which is 2 pi over 6, which is pi over 3, which as a decimal is 1.85? 1.0. What? 1.05. Okay. Sorry. Let's go look at this thing here. I'm probably doing this totally out of order, but I don't think it makes any huge difference. Circle cut into 6 equal pieces or pi over 3. So how many pi over 3's is this? You have 1 pi over 3. This one is? How many pi over 3's? So this is 2 pi. How many pi over 3's? Which is the same as pi. But we're just going to count it, right? So 1/3, 2/3, 3/3. How many? 4/3. So 4 pi over 3 doesn't reduce. This one doesn't reduce. And this one? So these two guys reduce. But the rest of them don't. Okay? So if I'm counting it, it's easy to say 1/3 pi. So, and a lot of times I'll just leave out the pi. So I'll say it's like 1/3, 2/3, 3/3. Okay, remember it's 2 pi all the way around, right? So 1/3 pi has to be up here, 2/3 pi. Now in degrees we know what those are as well, right? Because we went by 60 degrees. So 60 degrees, 120, 180, 240, 300, 360. Okay. Back to this. What if we split it into 8 equal sections? Then how big is each section? Eight sections is 360 divided by 8, right? Which is 45. It's what divided by 8 in radians? 2 pi divided by 8, which is 1/4 pi, pi over 4. So generally we refer to, don't say 1/3 pi, just say pi over 4. No, don't say 1/3 pi, say pi over 3. Don't say pi over 4. What's pi over 4? 0.78? 0.79? 0.789? Or 2 decimal places? 0.79? All right, let's go look at the pi over 8s. Let's back up here. Cut it into 8 equal pieces, each of which is, so this is, how many pi over 4s? This is 1 pi over 4. How many pi over 4s? 2. This one? This one? Again, think of it as you're counting by quarters. And remember, the whole circle is 2 things, right? The things are all pi. So the whole circle is 2 pi. I'm counting by quarters. I got 1 quarter, 2 quarters, which when I see it, I will just think pi over 2. 3 quarters, 4 quarters, which when I see it, I will just think pi. What's next? 5 pi over 4 down here, which I will think of as what? 3 pi over 2. This one is, and this one is, which I will think of as 2 pi. But if I'm splitting it into 8, it's easier to just go 1 pi over 4, 2 pi over 4, 3 of them, 4 of them, 5 of them, 6 of them, 7 of them, 8 of them. These guys are irreducible, right? You cannot reduce them. And they're the important angles because we've already covered this off. And this, and this, and this. We covered this off when we split it into 2. We covered these guys off when we split it into 4. Right? When we're splitting it into 8, we're not really worried about the 2 or the 4. We've done that. Okay, what's next? Okay, splitting it into how many? 12 sections. 360 divided by 12 is 30 degrees. 2 pi divided by 12 is pi over 6. Okay, reduced pi over 6. Pi divided by 6 is 0.52. And let's go look at this on here. Not here, but here. 12. Okay, so if you're splitting 2 pi, remember the whole distance is 2 pi. If you're splitting that into 12, it's 2 pi divided by 12, which is pi over 6. So what's this equal to? 1 pi over 6. What's this one? 2 pi over 6, which is pi over 3, which is one we already covered when we did the pi over 3s, right? But this is unique. What's this one? 3. What's this one? 4, which reduces. What's this one? Which doesn't reduce. This is. And as I keep counting, then we've got 8, 9, 10, 11. What are we interested in? Well, we're interested in the ones that are unique. We haven't done this one before. We haven't done, oh, we did do that one. If it reduces, we've already done it, right? 3 pi over 6 is pi over 2. If it reduces, we already covered this guy. We have not covered this guy. We already covered this one. We have not covered this. We have covered this. We have covered this. We have covered this. We have not covered this. So those are the ones we haven't covered, right? These guys have been covered. This was covered with pi over 3 because that's what it reduces to. This is 2 pi over 3. This is just pi. That was done when we split it into 2. We had this and this. This was done when we split it into 4. This was done when we split it into 6. This one and this one and this one. Okay, and so on. All right, what do we got? All the above angles are considered special angles. So in degrees, they're all multiples of what? (30) or 45. This is a multiple of 30. This is a multiple of 30. This is a multiple of 30. Okay, and then 45. This is also a multiple of 45, but it can be covered off. So they're all multiples of 30 degrees. So the special, and you remember back to 20-1, we did the special angles and triangles, and those angles were 30, 45, and 60. Okay. Or in radians. So what's 30 degrees in radians? Pi by 6 or pi by 4. If you count by pi by 6s, you're going to cover off almost all of the special angles except for the pi by 4s, and the 3 pi by 4, and the 5 pi by 4, and the 7 pi by 4. Okay. If you count by 6, you'll cover off the pi by 6s. 2 pi by 6 is pi by 3, so you'll cover off the pi by 3s. 3 pi by 6 is pi by 2, so you'll cover off the pi by 2s and the pi's. Okay? And then the only thing that doesn't get covered by this guy is the pi by 4, the 3 pi by 4, or the 45, the 135, the 225. No. Yeah, 225 and the 315 in degrees. View demo graph. View demo regarding Earth's rotation. Write the exact values, special angles at the ends of each circle in degrees and radians. Okay, so I think we've already viewed the demo. So we can just go through and do this. So in degrees. Well, you should just be able to look up the page. Well, okay. So this is 0 degrees, right?
Yeah.
Now, what's the next one? It's going to be 30 degrees. This one is 45 degrees. Then we got 60, and then 90, and 120. Okay, so the 45s are along here, 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 and here. Those are my multiples of 45, right? So it's going to be 45, 3 45s, or 135 degrees. Okay, this is the 30s, so 150 degrees, 180, 210. All I'm doing is adding 30s, right? But here's another 45, right? 180 and 45 is 225. Then add 30, not to this, but to this, right? 30, and then another 30 takes us to 270, and then 300 degrees. Oh, and this one's a 45, so it's halfway between 270, well, and add 45 is 315 degrees, 300, 330 degrees, and then 360 degrees. Right, so 0 or 360, which I'm going to squeeze in here. 0 degrees, 360 degrees. Okay, this one's in radians. So let's start off by just doing the 2, right? This is 0, this is pi. That's 2. We split it into 4. This is pi over 2. This is 2 pi over 2, but it's already covered. This is 3 pi divided by 2. So let's split it into 4. Let's split it into 8. 8 is going to be this one, right? There'll be 2 in each quadrant, so 1, 2. So this is pi over 4. Pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. That's why I count by pi over 4s, and I don't go pi over 4, pi over 2. I go 1 pi over 4, 2 pi over 2. Or sorry, 2 pi over 4, but it's already written. 3 pi over 4, 4 pi over 4, but it's already written. 5 pi over 4, 6 is already written. 7 pi over 4, and then 8. Now we go into 12 pieces. We count by pi by 6s. 1 pi over 6. Well, actually, no, we could do the thirds, right? So we could do the 6 pieces. Okay, so 1/3. 2/3, 3/3, 4/3, 4/3. Oops, wrong place. 4/3 down here. 5/3, and then 6/3. And then we go with 6s, right? 12 pieces or 6, so pi over 6, 1 6, 2 6, 3 6, 4 6, 5 6. 5 pi over 6. 6 6, 7 6, 7 pi over 6. 8, 9, 10, 11. And there we go. Okay, memorize that. No, actually, you got to know more than this to memorize this. All right, but you could just think, I'm counting by 12 pieces, etc., and so on. Right? I'll show you different ways to memorize the unit circle. And then you can go on YouTube and look up ways to memorize the unit circle and just find one that you like. Like if you don't like the one I give you, you say, that's all confusing, you can go find one. So we don't care how you know the unit circle, we just care that you know the unit circle. Okay, not today. You don't need to know it today. Okay, how do we convert degrees to radians? Or radians to degrees? So there's got to be a conversion. We know that 180 degrees is how many radians? If 180 is halfway around the circle is 2 pi, so 180 degrees is pi radians. So 360 degrees is how many radians? 2 pi, right? Just double this, you get 360. Cut this in, or this 180 is, well, pi. So fill in the rest of this chart. 90, if I divide that by 2, whatever I do to one side, do the other side. What's 1 degree? One degree is pi divided by 180. Okay, how can we express any angle in radians? So they give you an angle in degrees, you need to be able to convert it to an angle in radians. We can use the conversion above to convert between degrees and radians, just like we converted between centimeters and inches. Using unit analysis, convert the following into radians. So you have 130 degrees. So what we'll do is we'll say, I know there's a pi and a 180, and I need to put degrees on the bottom so my degrees will cancel. So this is like a rate. That's not like a rate, it is a rate. There are pi radians per 180 degrees, right? If I multiply these guys, degrees cancel. I'm left with 130 pi over 180, which is 13 pi over 18. Okay, and then I can work that out as a decimal if I need to. What did it say? Special answers, and then to the nearest hundredth. So it works out to 2.27. Now, if I want to write, again, if I don't put any units down, as long as we understand that 2.27 is an angle, then it's an angle in radians. Okay, and if I want to put units, I will just write rad. So it's 2.27 rad. Okay, so if you want to show the radians measurement, okay, and again, if it's an angle, so if you say theta equals 2.27, or not in this case, you would say 130 degrees equals 2.27. Usually you would add rad, just to show I'm converting it to radians. 312 degrees, okay, again, set up your rate. This is the rate, right? Pi radians is equal to 180 degrees. You could say, I have degrees up top, I need degrees on the bottom, unit analysis, right? Degrees will cancel, so we are left with 312 pi over 180. Degrees have canceled off, right? No more units here. No units, you're in radians. Okay, now I can do that as a reduced fraction. Just go 312 divided by 180, which I can immediately write in here as something pi. We'll always do it as a reduced fraction if we can. So what is 312 over 180 reduced to?
26 over 55.
How much? What's 26?
26 over 15.
Over 15?
Yeah.
Okay. So it's 26 pi over 15, and if we want that to the nearest hundredth, it works out to how much? 5.4. What? Speak up, I'm deaf, I can't hear. 5.44 is what I have. Who rounded? Is it? Bad key. Okay, so 5.45 I am told, rounded to the nearest hundred. If you have problems rounding, set your calculator mode 2. Right? Instead of float, set it to 2, it'll round for you. Pi radians is how much? 180 degrees. Complete the following table. So really the one you're remembering is this, right? I mean 2 pi is 360 degrees, right?
Yeah.
You're remembering this guy. Pi radians is 180 degrees. So what's 1 radian? Well, you know, 1 radian I will divide. If I want 1 radian here, I'll divide both sides by pi. And I'll get 180 over pi. Right? Which is like 6 point something. Or 60, it's like 57. I think it's 1 radian's about, it's just shy of 60 degrees, right? Because it's just a little bit more than 6 rotations. So if it were exactly 6 rotations, then it would be 60 degrees, but it's a little shy of that. It's like 57.8 degrees or something. But this one's 90 degrees pi. So just think 180 divided by 3, 180 divided by 4, 180 divided by 6, and 180 divided by 180. Okay, so that last one will be how much? 1 degree. Okay, so 1 degree is pi divided by 180. The radian measurements can be converted. So you have pi over 10. So what you think is, I want pi on the bottom, and I want whipped cream on the top, or ice cream. I say that because Costco has the pumpkin pies, giant, for like under $6. Okay, pi's cancel. You're left with 180 degrees divided by 10, which is 18 degrees. It's not even all that approximate. It's actually exactly 18 degrees. 6 radians. Again, you put pi on the bottom. You put 180 degrees up top. You're going to have to multiply this out. Okay, so 6 times 180 is what, like 1080 or something? So 1080. So it's going to be 1080 divided by pi. What does that work out to? It's got to be just shy of 360, right?
Yes.
So
343.77.
343.77 degrees. Okay. So using your analysis versus 6 range in 2 degrees. So yeah, right, because 6.28 would be 2 pi, or 2 pi of these would be 360 degrees, just shy of 2 pi, just shy of 360. Makes sense. Make sure degrees on there, 18 degrees. Don't write 18, that would be radians, and that would be horrible to lose a half a mark for not putting a degree symbol in. Complete the table below. Angle in radians, exact value, angle in degrees to the nearest tenth. I leave this for you as an exercise, right? You can do that. You may have noticed that when the angle measurement is in radians, there are no units. By convention, an angle measurement is considered to be in radians unless otherwise indicated, which is there's a degree symbol there. For instance, an angle of 90 would be considered as 90 radians instead of 90 degrees because there was no units provided. If you want to write the units for radians, it is customary to use rad. Okay? So it doesn't hurt to use rad. That distinguishes it. However, do not throw a degree symbol in and then write the word rad after it. That just confuses everybody. It's like, which is it? All right. Now, today, up until today, many of you did not know what a radian was. Who knew what a radian was walking in here? Okay, a few. 27 weeks from now, when this unit finishes, right, which is November 12th. All right, November 12th. It's a while. It's a month and a week. 5 weeks from now, when this unit finishes, you are not even going to know what a degree is anymore. You will not be thinking in degrees. Okay? You, by the end of the 5 weeks of this, you will be thinking in radians, and you will be wondering why they invented degrees in the first place.
Why don't we just do that?
Okay. So, right now, you just found out what a radian was, or you might have known. 5 weeks from now, mark my words, 5 weeks from now, you'll just be wondering what this whole degree thing was all about, because you will be thinking in radians. Okay? So, to start thinking in radians, we've got to start thinking in radians, right? Okay, 3 pi over 8. So where is 3/8? Now think of it this way, right? Just think 0, pi over 2, and pi, 3 pi over 2, and 2 pi if you like. So pi over 2 is what over 8? So pi over 2 is blank pi over 8. We'll get some more lunch. It's 4 pi over 8. So is 3 pi over 8 to the left of that line or the right of that line? If this is 4/8, where's 3/8? Before. Okay? That's how you figure out where you're at. Okay? You have, get a common denominator, right? If that's pi over 2, it's 4 pi over 8, so 3 pi over 8 is short of that. I'm going to indicate an angle of 3 pi over 8 by indicating a positive rotation. Okay? And what is my reference angle for this? It's the same, right? It's 3 pi over 8. So here we can write in theta is 3 pi over 8, so I'm indicating, and the reference angle is 3 pi over 8. Okay, negative 2/5. All right, so I got to go this way. Now this will be 5/5, right? Because it's pi. So this is negative pi or negative 5/5. This will be 2.5/5, right? So where's 2/5? It's going to be in here. Okay, so you need to figure this out, right? That's pi over 2. If I make that fifths, which is a weird thing to do, it becomes 2.5/5. So I want 2/5, so I'm just going this far. Okay, got to make sure you're in the right quadrant. So this is theta is equal to negative 2 pi over 5. What is my reference angle? 2 pi over 5. Yeah, just the angle, right? Because the reference angle is this angle, but stated as a positive, so it's just 2 pi over 5. No heavy math yet, right? So a negative rotation angle in the fourth quadrant is the reference angle when you just turn it positive, right? It's the reference angle. Beta is 4 radians. Okay, well this is 1.57, this is 3.14, this is way bigger than that. So 4 is somewhere in here. So beta is 4 radians. What's my reference angle? This is the reference angle. Yeah, do we want exact or are we willing to take... Okay, what's exact? Give it to me as an exact value. Okay, it's going to be 4 minus pi, right? So it's like, well, I went pi radians and then I went some more. How many more? Enough to get to 4. So what's my reference angle? Well, it's the difference between 4 and pi. Right? Because you went, so it's 4 minus pi. If we said to the nearest hundredth, then you'd give it to the nearest hundredth. But we didn't. Negative 1.6. What's this? That's negative 1.57. Right? Half of pi is 3.14. Negative 1.6 is just going to be barely across there. What's the reference angle? Expressed as an exact value.
What is that for 1?
Yeah, pi minus 1.6. So if I went all the way to here, I would be going pi. My reference angle is this. So it's pi minus this little chunk here, which is 1.6. So it's pi minus 1.6 radians. Okay, so you just figure, I got to get to the x-axis, right? And so to get to the x-axis, I got to go pi. But now to get my reference angle, it's like pi, but there's this chunk missing. This chunk is 1. Well, it's not really 1.6, is it? What is it? Oh, no, sorry, it is. Yeah, because this is 1.6 and this is pi. Yeah, so it's pi minus 1.6. My bad. Yeah, it's pi over 2 minus that. Yeah, you don't want to go with that number, right? So we could say it's pi over 2 minus this chunk here, but we can't get that exactly. So instead we'll say this is pi. If you subtract this from it, you're left with this, which is now a total mess. Okay, so negative 1.6 is just over negative 1.57. If you went pi and then subtracted the 1.6, you're left with the reference angle, theta r. Okay, so pi minus 1.6. Okay. Different standard, by the way, we're not going to get through all of this today, probably. It's pretty safe to say at this point, right, with a few minutes remaining. We'll finish it off Wednesday. There is another lesson, but it's a short lesson. Okay, well, we're still going for now. We'll just go to the bell. Different standard position angles with terminal arms in different quadrants can have the same reference angle. I think they're called coterminal. Complete the following table by stating the standard position angle between 0 and 2 pi. So, standard position angle between 0 and 2 pi, another word for that is the principal angle. So the principal angle is the smallest angle between 0 and 360 in degrees, or between 0 and 2 pi in radians. Okay, so we're talking about a principal angle. What's the principal? That way we can all talk about the same angle. It's not, it's 100 degrees. No, it's negative 460. No, it's 260. No, actually it's negative 260 or 460, right? So we can talk about what's the principal angle. What is the smallest positive angle between 0 and 360 or 0 and 2 pi? Anyways, so complete the following by stating the standard position angle between 0 and 2 pi with a terminal arm in the indicated quadrant. Okay, I got pi over 4 in quadrant 1. That's my reference angle. So what's my angle? Same thing. The quadrant 1 angle is the reference angle. I have a reference angle of pi over 4 in the second quadrant. So this is pi over 4. Question is, what's this? Yeah, so this is pi. So you got pi minus a quarter, or 4 pi over 4. Okay, so we'll just write it as pi minus 3 pi over 4. But be willing to think of pi as 2 pi over 2, 4 pi over 4, 3 pi over 3, 6 pi over 6, 12 pi over 12, right? So when you're counting your way around, then you just think of it. Pi over 2 could be pi over 2, could be 2 pi over 4, 6 pi over 3, etc. Or sorry, 3 pi over 6. Quadrant 3 angle. So if the reference angle is pi over 4, what's the quadrant 3 angle? 5 pi over 4. Okay, this time we want pi plus pi over 4, right? So you've gone pi, and then you're going another pi over 4.
That's pi minus 1.
There, now it's a 1. Quadrant 4 angle, if that's pi over 4, then my rotation angle is? So 2 pi? Yeah, but think of it as 8 pi over 4 minus 1. Okay, so whenever you're thinking of pi or 2 pi, think of 2 pi as being 8 pi over 4, 10 pi over 5, 12 pi over 6, right? Anything that's equivalent fraction to 2 pi. So 2 pi over 1 is 4 pi over 2, etc. Right? So in this case, I want 8 pi over 4, which is 2 pi minus 1 pi over 4. Gives me 7. All right. What's left to do? Oh, let's stop there. So you could fill in the rest of this chart. Okay? So before Wednesday, fill in the rest of this, and we'll pick up there on Wednesday.